Welcome, Professor Bright here, and in this video series, we're going to define the trigonometric functions and then look at some of their properties and whatnot along the way. But to begin, we need to figure out what the trig functions are, and to do that, we're going to talk about the unit circle and revisit this concept of arc length that we saw in the last section and stuff. So let's go ahead and get started. You can see our learning target is defined here, and then the different things we need to do as a part of that learning target. Again, these are super important for assessment. These are what I'm going to use when I write tests. So make sure you can do these by the end of this section. If you can't, make sure to reach out for some help. So to begin, we're going to just say for this entire section, we're going to work with the unit circle. And you might know that a unit circle is a circle. So, but when we talk about the unit circle, algebraically, it's defined as this x squared plus y squared is equal to 1. And when we overlay that on a Cartesian coordinate grid, that really gives us a circle that is a radius of 1 centered at the origin. So the origin's right here, and then we go out 1 unit in every direction, and our circle would hit the axes at this point. And so, oops, let's undo that. There we go. And I am going to draw my best circle that I possibly can. I'm freehanding this, so forgive me if it's a little, well, yeah, that's really not a circle. We'll take one more stab at it, and then we're just going to say it's going to be a circle. Okay, it's a circle. Okay, but so it's a unit circle. Again, radius 1 centered at the origin. That's what we mean when we talk about the unit circle. So these 4 points are always on the unit circle. So we have, oops, that should be a positive 1. So 1, 0 is on the unit circle, 0, 1, negative 1, 0, and 0, minus 1. Those are all points on the unit circle. And then if we were to look at the distance from the origin to, say, any given place on the edge of the circle, also known as the circumference of the circle, that distance we call the radius, and that's just going to be 1. Okay, and just as a nice side remark, if you're like, oh, I kind of remember this formula, yeah, you probably have seen it back in high school mathematics at some point. And for a general circle of radius r with a particular center at hk, this is the formula that you might remember. Okay. Nevertheless, we want to start today by taking a look at this and then thinking about the arc length. Okay, we learned about arc length. We remember this formula: S is equal to r theta, and r is our radius of a circle, theta is the central angle, s is the arc length. Well, in this section, they don't use s, we use t. Why the change? Honestly, it's just because s's look like 5s. I think that's all it is. But what we're going to imagine is that we start at the point 1, 0. And from this point, we travel counterclockwise along the circumference of the circle, the edge of the circle, okay? And we travel by some distance, we call it t, the arc length, okay? And so we think of this here, and the point that it ends at, we would call that the point xy, okay? And it happens to be that this arc length, we can think of that as an input into a function, and then we can say, okay, well, we go along some arc length, and then and correspondingly, once we put in that arc length, we get some different ratios we can form using the x coordinate, the y coordinate, and the radius of the circle, which would be 1 since we're on the unit circle. Okay, and that's how we get these trig functions. So if we look at the ratio of the y coordinate to the radius, again, that r is 1, then we get the sine function. It's not sin, it is sine. And then if we do 1 over the radius over the y coordinate, that would be the cosecant. So kind of the reciprocal of sine. Secant is 1 over the x coordinate. So again, radius over the x coordinate. Cosine is just the reciprocal of secant. So the x coordinate over the radius, which is 1. Tangent, y over x, so the ratio of the y coordinate to the x coordinate. And cotangent is the, again, reciprocal of tangent. Okay, so we get these functions. Fun. These are our trig functions. Notice that when we talk about these, I am using the language of functions, meaning we have an input of t, arc length in this case, and we get out a ratio of ratio of either the hypotenuse, or the distance from the origin, or from the center of the circle to the edge of the circle, and the x and y coordinates. Okay, so whichever trig function we're interested in, we'll be sure to tell you, but for at least this first little while, we're just going to write all the trig functions down and form the ratios accordingly. Okay, when we write the trig functions, it's actually super important we're careful with notation. The book, and me too, I have a habit, I'm not going to say it's good or bad, but I have a habit of just saying, just writing sine t, for instance, without the parentheses around the input or that arc length. But in reality, that is the same as if I were to include parentheses. One thing that students tend to struggle with is that when they see sine and then there's a gap and then there's a t, they tend to think of that as multiplication. So just be aware of this and do not make that mistake. It is not saying sine times t. They are distinct. They are not distinct things. They are one and the same. Okay, and then also note that here we defined going counterclockwise as t, positive t, and if we were to have, say, a negative t, that would just mean instead of going clockwise or counterclockwise, we're going clockwise. So that would look something like going this direction instead. So this would be like a minus t. Okay, so it's just, if it's positive, counterclockwise, clockwise, if it is negative. Okay, so just as an example here before we end this video, okay, so it says let t extend around the unit circle counterclockwise from the point 1, 0 to the point that. So okay, I need a picture, and I highly recommend drawing pictures whenever you are working with trig functions. It's super helpful. So where I'm going to call this point 1, 0. Okay, and then it says counterclockwise from the point to the point -3/5, 4/5. So now this is on the unit circle, right? It says around the unit circle. This point -3/5, 4/5, that would be somewhere in the third or second quadrant. Okay, so this would be the point -3/5, 4/5. Okay, and t would then be the distance along the edge of the circle, that arc length from there to there. It says, so draw t. Oh, okay, I didn't even read the instructions, but I have a drawing. And it says find the value of tangent of t. Okay, now tangent of t, if I recall, tangent is the ratio of the y-coordinate to the x-coordinate. So this is going to be the ratio of the y-coordinate to the x-coordinate. And when I do that, let's see, this is going to be 4/5, which is the y value, divided by 3/5. And if I were to, change this to multiplication by the reciprocal, so 5/-3, multiplied by the reciprocal, 5/-3, boom, 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 and then this would reduce to -4/3. Okay, so that's the ratio for tangent. So I could go through and form the ratios for the other trig functions, but that wasn't asked in this exercise. So some quick definitions of the different trigonometric functions. Again, the main point here was to introduce this working on the unit circle, again, circle of radius 1, and then with that unit circle, we can introduce this arc length, or reintroduce this arc length concept, just changing our notation from s to t, and then using that arc length as the input of a function to form our trigonometric functions, and then the output of those trigonometric functions is going to be a ratio of one of at least two of the quantities where we have the x-coordinate, the y-coordinate, and the unit circle radius.